know me because I teach the class CSC701 for student semester 2, and also the student come from Shah Alam in computer science. Okay. So before we go further, so we're going to have a class every Sunday around 8:15 lah, 8:15, and from your background, okay, maybe 10% of you, 10 to 20% come from CS230. It's going to be the same material. 50% of the material is going to be the same. So please bear with me. Stay. I think it's a good refresh review. I'm sorry because it's the same thing, but we have other subject, other topics that we going to. It's not the same as the degree subject. Okay, so for the ex student 230, so first is advantage to you. It's easier to understand. But I think we have a friend here. That the friend here is not in the CS field. It's a CS background. So so I decide to go one by one. So firstly, I want to discuss very fast, because maybe it's not very difficult for CS student. But we have your clip here that is not in the CS background. Okay. So please be patient. We go through one by one, not very fast for this class. Okay. So I share the presentation. Any question before we start? We're going to go through the syllabus, and then we're going to start. Okay. And for the student that have the process of changing to CS707, so I think you can do. It's okay. So I think by next week, I think you formally in the C7, and you can use the new feature for the attendance. So for this class, going to use new feature for the attendance. Class. Okay, I'm using this camera plus microphone. I'm not sure whether it's good or not. Alhamdulillah, you're choosing. I want to show you this. Can you see the website? This website?
Yes.
Boleh sebut?
Yes.
Yes. I think most of you, half of you know about our department. I think I think so lah. I'm not sure. It's one of the department in ITM lah, because we have more than close to 80% having PhD. In ITM, I think not only ITM, the other university, it's quite rare to find 80% of the staff. So so that means you have at least 30 lecturers. You can be you can choose for your supervisor. Okay. But we this year we have 6 lecturer pension. So we have only so this year we have 34 lecturers, and this is me. Okay. This is me. I hope you can see. This is me. Okay. And this is my room, T132. You can come if you want. You have to make an appointment. And then that's all for me. You can email. This is my phone number. Most of the time I'll be in my room. Okay. Weekdays. Okay. I do come to the almost every day. Every day I come to the office. But most of the lecturers they choose work from home. For me, I choose work from office. You can come to my office anytime, weekdays, right? So this is my room T132, and this is my room number, telephone number. Okay. All right, this is me, and then next we go to the uh, syllabus. So as I mentioned just now, we is very similar to degree subject. Okay, 50%. Okay, so let me go through. So this is compiler construction. So good thing about this class, they only discuss about one software only. Okay, so that means there's only one software. You just discuss about one software, a compiler. That's good. So that means it's not very broad, specific to one software. So we have 14 weeks, and I will put this team of work in your future. You can check in your future, maybe later this day, today. And we are going to use, this is come from the book. This topic come from the book, going to be the textbook, and I give you the e-books of this book in the U picture. Okay, you can go through this book. And my slide going to be, I have a slide that is all the slides come from that book. Okay. So today we're going to cover more than one chapter, more than one chapter, and then go to chapter 2, chapter 3. This is chapter is almost the same in degree. And then when it comes to chapter 5, we have one special special topic that we're going to take from other book. So I'm going to give you the other book for chapter 5. This is quite difficult. This is new from chapter 5. And then start from chapter 5, chapter 6, and chapter 7. This is new. This is new for master program. Okay. So as everybody know that we have two 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 break for Hari Raya and for the Sabah and Sarawak Hari Raya. That means that's good for this week. This semester we have extra 1 week compared to last semester. Okay, because of we have extra break. Okay, so that means I put a date there, the time that we cover, and for the assessment, this is the original assessment. 20% for the test 1, 30% for test 2, assignment 30%. Quizzes, we have 2 quizzes, 5% each, and a mini project 10%. Passenger is B. I'm going to use this book, Compiler Theory, Tools and Example, Java Edition. Okay, this is the ebook that this is the ebook. Okay, and then because of the ODL, this is the way how we just to minimize the number of assessment. Okay, but still represent the original assessment. Okay, you can see this table. Actually, this table represent the original assessment. This is not assignment. Actually, I made a mistake. This is not assignment. This is assessment. Assessment 1, assessment 2, and assessment 3, and final assessment. So the final assessment is the test 2 actually. So we call it final assessment, but actually it's a test 2. 30%. 30%. And then we combine, actually I'm going to combine quiz 1 and test 1. So it's become 35%. And then we have quiz 2, another 5% for assessment 2. That's all the different. Others is the same. It's just like because we have all 6 assignments for 30%. And the only difference is instead of we have two quizzes, we only have one quiz, online quiz, and we have first test is an online test, but will cover 35%. And the online test means that we're going to using U future for the test. Okay, and then the last final assessment will be percent. This is before the meet, we do the same thing. Before the submit, the test is the same way with that we are it's an open book test for the not because of pandemic. It's the implementation of the open book test. I did it last long time ago. Okay, so this is not but this is new for other subjects. The new other subject that before we have final exam or closed book test, but now we cannot control. We give the open book test, take home test. Okay, this is for the assessment. So the assessment, the assessment, most of the assessment is do by yourself at your home, your place. Okay, assignment, test two, or final assessment will be you will doing the test at your place. But the only test you need to do online is test one and quiz. Okay, that's two. Where you need to do it online. But other assignment and project do by yourself at your location. Okay, so you need to submit it using email. Okay, all right. That's about assessment. About assessment. So one more time. Start, so we're going to start just this class today. If you don't have any question, about the syllabus and assessment, saya tak tengok. Okay, so that means that you don't need to buy any book. So you're going to use the e-book. You don't have to buy any book. Okay. Actually, the one of the topic that I mentioned just now, we're going to take one topic. Okay. That's all for the syllabus. That's all for the now. This is quite familiar for my student. There are two or three students, my ex-students. So I just using the same slide. Okay. All right. So before for part two student, although it's a little bit repetition from CS701, but the approach I'm going to take is quite different from the other class because they are using a mathematical notation. So for this class, the mathematical notation will be few. Okay? So what come from they only describe the method. We are going to describe not using a mathematical description. So the described by a sentence. So the approach we're going to take maybe a little bit different from, although that class cover also the compiler. Okay. All right. So one more thing, because this is ODL, ODL. So that means I go to talk about 2 hours and 30 minutes. Okay, 50 minutes for each hour. and that's why we stop around 10:40. We're going to stop around 10:40 or 10:45, something like that. So that means there is no break for me lah. But if you want to break, you of course you can do by yourself. So no need to ask me. Just go for the break. Okay. So I'm not going to stop. I'm going to talk about 2 hours and 30 minutes. Go through this slide. If you have any question, just ask. Okay, just ask for any question. We can discuss. Okay. So for this class, it's going to take 2 hour 30 minutes. It's a straight and no break. 50 minutes for each hour. So it's going to be 550, 50, 50, 2 hours 30 minutes. And I think we maintain starting at 8:15 every week, 8:15. So okay, uh, this is about compiler. This is about compiler, and compiler actually is a software to do a translation. Everybody know about the Google translation. This is the same thing. So we are having almost the same software like Google Translation to translate one language to another language. But the only difference, the Google Translator translate from one natural language to another natural language, which is both considered as a natural language. For our compiler, usually compiler will convert a computer language in different level. We are going to convert one computer language, which is a high level computer language, into low level computer language. This is just a little bit different from Google Translator. So today in your class, this class, we're going to study how to create the software. How to create the software that can translate high level language computer program into low level language computer program. So why we want to do that? Because the computer only can process instruction in low level language. Okay, that's why the objective of the compiler is to make our instruction to computer understand by the computer, then the computer can execute. Okay. In other words, a compiler is one of the most important tools in the computer era, in the modern era, in the in the internet or in the computer era here, okay, or in the latest modern technology. Okay? So we still need a compiler because so far that's the best way we can build the computer, where the computer process the instruction for the human in the machine code, in the low level code. That's why we build the compiler in order to ask the computer to do something in computer friendly language, to the real computer language, the real computer language that computer can understand. So in other words, all the apps in the mobile phone, all the software in the desktop should go through the compiler in order to deploy, in order to use it. Semua faham kan? Semua kamu faham lah. You understand all. This is why we need a compiler. Okay. Because of that, the computer only understand the instruction, a low level instruction. So because of the simplicity of the instruction, the computer, the machine need to know the simplest instruction. The simplest instructions such as add, mark, just a mark we can say is a manipulation of things, like we can manipulate a binary number by having the calculation, and then we move from one location to another location. That's only the computer can do. But this that the computer do will produce an output, a good output for human usage. Okay, so the computer can only understand, add something, move something, between CPU and memory. So I think we know about CPU, where we run the calculation and memory. That's the low level language that computer can understand, and we must ask the computer using this language. Okay. So in other words, a
Betul.
compiler is a software. Tak dengar tak?
Slide
Hello.
blank.
Tak dengar. Oh, okay. Okay, one more time and one more time saya I will one more time. Thank you very much. One more time sharing. Okay tak? You can see the slide?
Okay, nampak.
Nampak Hmm. It's just two slides. It's the second slide. Okay, so compiler is just a software translate. So if this is a software class, is a computer class. When you talk about programming language, you must know about IPO, input processing and output. This is the job of compiler. Okay, I think somebody want to uh, so this is the job of compiler, right? Compiler will if we talk about computer, what is the job of computer? Receive an input, process the input, and produce the output, IPO. Okay. So when we talk about all the software, the software has to go through this process. For the computer should accept the input from the software. Software will ask for the input, and when you process the software will process, the CPU will process using the software, and using the software, the CPU will produce the output, IPO. Okay. How
Doktor,
about the computer? Huh?
slide tu hilang
Yeah.
balik.
Memang pun saya tak masuk lagi.
Oh, okay.
Okay. Sebab saya, okay, thank you. Tak apa, tak apa. Nampak tak? Can you see? Can you see
Okay,
the slide?
boleh.
Okay. Tadi saya tak masuk lagi. Okay, thank you. Tak apa. Alright, this is the okay. Nampaknya saya kena. I have to go to my room. So I tend to have a class. This is my home. So actually, it's quite far uh, from the unified point. There's problem with the okay compiler. IPO, input process output, they accept the program. So the input for this software is a program written in a certain high level language, and the result for the software, which is a compiler software, produce an output that in the state of different language computer program. In this case, is a low level language. So that's all the job of compiler. Then we need to study how to do this. How to do this. And so, in other words, if we are talk about computer language, high level language, we are talking about a statement. The high level consists of statement like x equal to y, if X less than Y, this we call a statement in a high level language, and translate the statement into low level language. Low level language, the sequence of machine language. Sequence of machine language. So we take all this sequence of machine language, put it inside a CPU, and executed, we get the result. We get the answer output that meant for that mean that the that what we want from the high level language. We get the answer for the high level language. So we carry out the intended computation. Okay, so I think everybody know about compiler. Compiler as input and program is a particular high language and output a machine language for the target machine. So usually a language, a high level language is compatible to all the machine, but not the machine code. The name implies this code belong to a machine, a particular machine. So that means that different machine may have different machine code. So it's not compatible to all the machine. The code that produced by the CPU compiler depend on the where we want to run the program. The machine where we want to program, that's the code that the compiler will produce. Okay. I think kena cepat sikit, very long. So there is a term for a program that we going to input. We call it source program, and this belongs to a language. We call it source language, and the output is we call it object program and belong to object and language. So usually object program is a machine code in a binary form, and we cannot read it. When you try to open it, they may produce weird character. Okay? But for high level language, you have to read it because you produce it, you create it. So it's a form that you can read it. It's a high level language. But the machine code, only the computer can process it, and the only computer can understand, not the human. Usually, So as a conclusion, compiler translates source language program into equivalent. The most important part, the most important word here is equivalent. So that means one of the important job of compiler to make sure they produce the equivalent for equivalent in the language process. Okay, so they produce the low level language that have equivalent meaning, equivalent intention. All right. Because of that, because of the machine, we have a Java compiler. Java is a high level language. So we write Java code in order to ask the computer to do something. So in order the computer to do something, we need a compiler, Java compiler, to translate to the lower, to the machine code of a machine. In our case, it's Apple computer is a machine. And any gadget in this class, any gadget that any computer gadget, we can assume as a machine. Please. So another game that we are familiar, like Java, COBOL, Pascal, Python, Python, PHP. This is a high-level language. All the gadget, either is a desktop or mobile, we can assume as a machine code. Although the name of the machine code quite different. Like mobile that you are using, Smart Dragon, ataupun MT and so on. But we're not going to use that name. So we use the name of the gadget as a machine code name. For example, we have a Apple Macintosh machine code, and we have Sun machine code, and it's a mobile. We maybe have a Samsung machine code, but Samsung also produce a laptop. But for example, we have Xiaomi machine code. Not Xiaomi, Xiaomi also. Huawei also, they were going to produce the laptop. Maybe we have Oppo machine code. maybe we have what else? All the mobile phone we name it as a machine code. Okay, and the other thing is high level language, which we are familiar, like Java, C++, C, COBOL, all are high level language. The gadget all are low level language like Samsung, Oppo, Vivo, Poco, Honor, Huawei, and Apple, iPad, tablet, considered as a machine code. Okay, okay. So before we do it automatically using compiler, now you are the compiler. So before we ask the computer to do the translation, translate the first class in the chapter one, you need to do this. Your brain become the compiler. Okay, so that means you need to do the job of compiler manually. Okay, but the most important skill you need to know is the flow of the processing. The flow of processing is very important. If you don't understand or if you're not sure about the flow, you will not going to produce you're not going to you cannot uh, translate to convert the language. Okay, so because we want to produce another language that produce that have the same meaning, so that means the objective, the objective of our all the program is to ask the computer to do something, to produce something. So we convert it into another language that must produce the same thing. Okay. So in order to know to produce the new language, we must know the process of the original language, which is the high level language. And the main thing to understand what the program will do, you must know the flow of the process of the high level language. Okay. In this class, we only discuss about the basic uh, high level language, which consists of the control statement. That's all. We're not going to process or produce or process, convert a very complicated language. We are going to translate a small, a basic high-level language consists of only control statement. Okay. So this is the first control statement, is sequential control statement, which is consists of only one thing, assignment statement. So I mentioned that you need to know the process, the flow. Okay. So whenever you want to, although you learn about this arithmetic from primary school, so you know the flow already, automatically. So to do this, to store the answer to A, so that is the last thing you need to do, right? To store the answer to A using assignment statement. That is the flow. So when we ask what is the last thing you need to do in this process, high level language, from this A equal to B plus C plus D, of course, the last thing I want to do is to store the answer inside into A, right? Okay, that is the flow. You need to know the flow. So this is the flow. You need to know the flow. You need to do the multiplication first, followed by what? By addition, and after you get the answer, you must, and the final process, the final activity is just to store the answer inside A. We call it assignment statement. So if you know that flow, then you can create another process that follow that flow in order to get the same answer. Okay, so first we do the multiplication. So this is the assembly code where we can say it's a very close to a machine code. So machine code consists of binary digits. Okay, so it's quite difficult to understand. This is one step before we create a binary digit. Okay, we're going to learn how to convert into binary digits at the end of this class, this syllabus. So this is just, you don't have to write this one. This is what? This is, this is the explanation, documentation, comment. So this is a generic. Remember that is a machine dependent. The machine code is a machine dependent. Different machine have different machine code or different assembly code. So I can call for this class, this is a generic machine code. Okay. So everybody must follow my way because at the middle of the class, we're going to use this way in order to produce the assembly code. So I think when you study at the beginning of the class, come to the middle of the class is quite easy to continue because we already know how to write the assembly code. So what is a compiler? Compiler convert the high level language to the low level language. Okay, this is the low level language. So that's all for this the entire class. We want to study how to do that. How to convert the low level, high level language. This is Java-like language to the generic assembly code. So I will teach you the how to create the assembly code. So it's not many things you need to memorize. It's just less than 10. Firstly, the name of the instruction. So you must know what is the name for multiplication, addition, subtraction, and division. So this is a name for multiplication we call mult. For one activity in high level language, they will break into three activities in low level language. And the activities is quite because of the way we convert it should be consistent lah, consistent. So if you want to do multiplication, remember do the left side first. The left operand load in the R1. We are using the computation register, CPU register, we name R1. So where at this location we're going to calculate, do the process. So we need to transfer the value to the CPU and then we can do the calculation. That's why, but the name of CPU only one, R1 for the, so that means anything new come to the R1, the old one will be override, will be deleted. Okay, so that means R1 only can hold one data at a time. And the answer of the calculation will replace the original data in R1. When we do a multiplication, so R1 will hold the answer of multiplication. Okay. So in order to do the calculation, we need to put the thing that we want to calculate in R1. That's why we have load. What is the job of load? To transfer the data inside the R1. So the data may come from a variable named C. For this calculation, we have a C where hold the data, transfer to R1. So we need a load. And then the calculation come to. So that means in most 99%, 95% of the assembly code, we have two operands. Only two operand, one comma and two operands. So that only two operands. So the right operand is the one that we have the data, and the left operand usually is a R1, is a register, the CPU register. Okay, so we need to transfer first the data in C1 to R1. So that means first take the left operand in the high level language, load it in R1 using load using the load instruction, and then because it's multiplication, we mul with another variable which is D at the left side of the operand. Okay, and the right operand. This is left operand. Okay, so this is the way you must memorize the way. And then because R1 is a place to do the calculation and hold a new data, a fresh data. So the data that you produce in R1 should be stored in other location. So we have a instruction we name it store. Okay. So remove also load from left to right, from right to left. We transfer from right to left operand, but store the opposite way. We transfer from R1 to the left operand to the right operand and 10-1. Where come the name temp1, you can give any name. Okay. Usually we get a name, the variable name from the high level language. Okay. The variable name we use the same name but we capitalize. Kalau the in low level language is a lower case, but in the high level we make it capital, right? Okay. If C is lowercase, in high level language we make it capital in. So that means in to make it special for assembly code, everything in high, the everything in assembly code in uppercase. Okay, in uppercase. Okay. So and then we do the calculation. So we get a value, the answer in R1, and then we store it using store statement to a new variable that we introduce. Because we introduce new variable that to make sure it's not mixed with other variables. Every time you want to store something, you need to create a new variable. A new variable. Okay. To store a new answer, you must create a new variable to make sure it's not mixed with other variables. Name using this procedure. Name it. You can name it temp. eh, Temp because it's a temporary variable. So in your case, don't name it temp. Name it t, and then follow by a number. So every time you need to add a new variable, you increase the number of that number. Begin with T1 and then the next variable you name it T2, T3 and so on. Every time you want to store a new variable, a new value, you must create a new variable and the variable should be a new number at the left side of the name of the variable. Remember, That's why this is the first value we want to store. So I put it temp1. Next time use T lah, T1. And then this we want to add the answer to B. So B is the left side. So you need to load B first, and left and right. And then add to temp1. Add to temp1 R1, and then we get a new data stored in temp2. That's why this is a 2. This is a new variable to hold the new data. This is the current variable that holds the current data. T1. And then load and then load back. Although you say, oh, this is redundant, but it's okay. So that means one. So this is 3 is one process, another 3 another process, another 2 is another process. So for arithmetic calculation, we need 3 process, 3 instruction. Load, mark, and store. Load, calculation, and store. Load, calculation, and store. But for assignment segment, only 2, load and store only. 1, 2, and A1. So please, this is the way you need to do. This is the generic assembly code you need to follow. You may have your own code, but please follow my way. Okay. So because it's independent from one after the other, so we need to load back the temp2 to R1 in order to store 2 in A. So okay, it's quite long here, but it's very easy. But because it's the first thing you need to understand, to use the way, the style, so that means it takes time to process it to produce. So remember the most important thing in order to translate from one language to another language, the most important thing is you must understand the high level language. Okay, the meaning, how to write the meaning of the high level language, and also you must understand how to write a low level language in order to write the same thing in a low level language. The second thing, you must also know the process, the flow of the process of the program, in order to produce the same program in low level. So because they do the multiplication first, that's why at the top of the low level language we have the multiplication followed by addition, and the last thing we need to do is to do the logic of the flow is quite important. Remember. And now remember that we have what? We have we call the beginning of programming language, we call a control statement. Although control statement is not is a easy concept, but it's very important. In all language, programming language, they have a control statement. What is a control statement? Control statement consists of three kind of statement. The first statement is sequential statement, where we have one 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 statement after the other. We call it sequential statement. And then we have selection statement, selection control statement, where we see if statement to do the selection and to choose one statement compared to other. We have uh, selection. We choose only one from two selection. So we call it selection control statement. We are using if statement. And then the last one is repetition control statement, where we have or at least two kind of statement. We call it for statement and while statement. So the repetition statement that we are having a loop, I mean, we repeat executing the same statement. In this case, we need to jump. Both selection statement and repetition statement, control selection control statement and repetition control statement. You need to decide something. First, you need to decide something. Number two, because of the decision, we need to jump. Okay, another element in selection statement and repetition statement, we have a concept of jump. But for the selection statement, we have a forward jump. You have a forward jump. That means you only jump at the front of the front of the statement. We go further down to the statement. But for the repeating statement, we have both. Uh, forward jump at the far in front of the statement, and we have backward jump back to the beginning of the statement. Okay, so that's the difference between selection and repetition. Okay, so one statement we have another one statement is one of the repetition control statement. So you must understand this statement. It's almost similar, 100% similar in C++, C, and Java. And Pascal also almost similar. So they have a relation operator, or we call it Boolean expression. So we have a Boolean expression. The operator consists of any arithmetic operator and also the relational operator. Okay. This is how you write it. And then we have this is the body of the statement. Any statement of the language, okay, can be a body of the while statement. Okay, so before we can do before we can convert it into low level language, the most important thing you must understand the how you understand. If you understand the high level language, you should know the flow. Okay, so what is the flow of this the process flow? Okay, so when the computer want to execute or when we want to implement this deploy the one execute the statement, the computer the process going to be like this. They go to this one first. While that means that while is just a while lah. No, nothing at all. We not produce anything, but we do something here. Inside the parenthesis is a relation Boolean expression. Okay, so we execute this, and then if we have a true statement, true answer, we go to inside the body of the while statement, and then we execute this statement inside the body. After we execute this statement, all the statement inside the body, in this case only one, we need to backward jump, and evaluate the Boolean expression one more time. And then if we have a true statement, true answer, we go back inside the body of the while statement, and then we do the same calculation, and after that we have backward, we call it backward jump. In other words, they call it unconditional branch, unconditional branch to the early part of the statement, and then we evaluate, and then the third time, and we found that if we found it's negative or or false, we need to exit from the loop. We stop the loop by exiting from the loop. We have a forward jump to the after the body of the outside of the body of the while, and we stop the processing. That's a you need to know the flow. So in order to create the same flow, we need to do something. We need to have a branch and a location to jump. Uh, so in low level only we have a way to jump. We call it branch. Okay. And also we need to jump or branch to a location. We call it label. Right? We call it label. So we have branch or jump, and we have a way, the place we want to stop, we want to go, we call label. So in assembly code, we put it branch to B only, and label to we name it L, because branch can branch to anywhere. So branch they have a followed by the place we want to branch, and the label that the label is the destination where you want to branch or to jump. So we may have many label. Remember that as we have we can have as many as we want the temporary variable is also the same thing as the label. You can have as many as label you want. You can have it. But to make it easier to organize, we name it using a number. L1, L2, L3, L4. It's the same as temporary variable. T1, T2. Remember, you cannot produce the same label twice. You produce the same label twice. The problem is it's a conflict because you will not know where to use. So label is a decision where you want to jump. If you have two labels with the same name, it's a conflict. Where you want to jump to the first or second label. So the label should be unique. Every label should be unique because it's the place where you want to jump. Okay. So remember, must understand the process, must understand the flow. Okay. So this is the answer. So in order to do this, you need three labels, three location to destination to jump. Okay. So remember that you must produce the same thing but in the in the assembly code. So remember you need to process this one first inside the parenthesis. The parenthesis will do nothing, will produce nothing. But you need to put a parenthesis as a part of the syntax of the high level language. But the thing that will produce the low level language is we call it Boolean expression. Okay. So there are uh, two operators there. One is a relational operator, another is arithmetic operator. If you have two this one, you need to do the arithmetic operator first, followed by the relational operator last. So that means you need to do what first? This is very important for the compiler because they want to make sure which one you want to do first. So you must know the priority. The priority is if you compare the relational operator with arithmetic operator, you need to do the arithmetic operator first. So that means we do the addition first. Remember, load A to R1, add B to R1, and store R1 to T1, the first temporary variable. And then this is compare. If you want to do the same as one, I think I can I will enforce that thing supaya kamu tak confuse. Saya buat yang ni. You can do also like this. I think better you do load R1, T1, R1 X, and then compare R1. I think this is much better lah, consistent lah. So also you can do that. I think it's better do like this lah, and we make it consistent. So compare, we have load, compare, and price. Okay. So this is the one. So that means you must know how to do this. I think this one quite straightforward. So for the Boolean expression, you need to do the arithmetic first. Then we have the Boolean relational operator. So in mathematics, in programming, everybody know we have six relational operator. We have six. So we have equal, we have less than, this is less than, we have greater than, we have less or equal, we have greater or equal, and finally the sixth one is we have not equal. Okay, so this is less. So so do we have one instruction called branch if less. So the branch is less. So that means when do the comparison, they will produce true or false based on the last segment here, the last instruction here. So compare is a compare instruction must follow by branch instruction. This branch. So branch instruction they have six instructions depending on the relation operator. So that means they have six branch with condition instruction based on the relational operator. We have six relational operators. So this is BL represent if the less than is true. Branch to where? So another thing in a branch because they have only one operand, only one unique operand, which is the location to jump. This is a label where you want to jump. So that means after you have true here, you want to jump inside the body. Jadi the jump L2. L2 is the location where we start the body of the one segment. Okay. If the compare is false, they will skip this one. This only execute if the compare is true for BL. So because BL is false, you need to exit from the loop. Jadi we have B. B is the another branch operator or branch instruction. For the name is unconditional branch. B only, not attached to any relational operator. We have the conditional branch with six conditional branch, BL, and later I will tell you another five names. Okay. So this is unconditional branch. So that means without any compare, we just when you execute this one, just branch jump to the location which is the next operand, the only operand for the branch is the where we want to branch, either forward branch or can also backward branch. Okay, in this case, it's forward branch. Exit from the loop, and then we need to convert the body of the segment. It's a multiplication, load, mul, and store. Remember that it's number, just put the number there, number 2, and then put the X there. This is lowercase, but we make it capital here. And then this is the second time we call T, we call a table variable, that's why we name it T2. Okay, and then load back T2 and store in X. Okay, and then this is branch. Because one segment we need a unconditional branch back to the beginning of the loop to the Boolean expression. Okay, so BL1. So we need to put L1 here. This is the beginning of Boolean expression. Okay, so after they do the body, they go back to the Boolean expression to check whether we can make a loop or not. If we can make a loop, this is going to be true. Go inside the body and go back to that. So that means we have the same process of the high level language compared to low level language. Okay. All right. All right. I will change into this. This is, I think, much better lah. We are using R1. All right. So any question? Tak apa lah. We go to the next one. Okay. I think kamu tanya kemudian. Okay. So this is everybody in class must, because it is part of the test. I give it here. This one you must be able to produce this one. Okay? This is optional lah. The comment is optional. You don't have to write the comment, but you must write the machine code. Okay, must write down the main thing about compiler. The main thing, you must make sure they have the same meaning. Eh? They have the same meaning. The high level language with the low level language, they have 100% the same objective. Eh? To the main thing. But sometimes when you try to make it a general way to produce the answer, the low level language, sometimes we create the inefficient assembly code. Sometimes, most of the time lah. That's why in our class, in this class, we have a way to make it at the end of the syllabus. There's a topic we call the optimization, to optimize the compiler. But one more time, the most important thing is the equivalent, not efficient. The efficiency is quite important, but not as important as the the correct code generation, the correct. So I think I skip this one. It's not important. And sometimes, sometimes we have most of the time right now, instead of we are producing the assembly code, some software compiler, they execute the assembly code. Okay, so this software we call it interpreter. Interpreter actually is a compiler that include the execution of the assembly code. And then remember that this is interpreter. Kalau interpreter for this input of the compiler, of the input of the software, interpreter will produce 12. But the compiler will produce a assembly code. No answer. The interpreter will produce, but the interpreter also have to follow the compiler. They need to produce this one and then execute this one, and then we get the answer. So that means they hide this, not share the assembly code with you. They just execute the assembly code and give you the answer. Okay, in our compiler construction, we're not going to produce the print statement. Okay, so for the print statement, this is the way: push the one you want to print and call write. So you have, if you have a print statement, this is the two statement you need to do. You need to push something that you want to print, which is a plus b, which is here 10, 10, 10, 1 and 10, and then call write. So this is the standard way we can use for the assembly code. For the printing, can be print, can be system.out.ln, but the main thing, you need to push the one inside the parentheses. Okay, all right, this is assembly statement. So load store for assembly statement, load store for assembly statement, and then we have to multiplication, save the answer to temp, and then we push temp and write. And that's why there are two important process when you talk about a compiler. One is the time process, the process of creating the assembly code. The time we create a assembly code, we call a compile time. When we process to create assembly code, we call it a compile time. When we make a mistake in the high level language, the compiler will not understand, and this will give you an error. The error, because of the incorrect high level language, we call it a syntax error, a language error. Okay, but if you successfully build the assembly code and then we want to get the answer, but there is a problem when you try to get the answer, at this time, we call it running time error. So when we execute assembly code and we get in trouble, you have a problem there, you have an error there, we call it runtime error. So when you do the assembly code, when you create assembly code, the compiler will not check for any mathematical error, any calculation that in mathematics is wrong, any storage in the store a data in the wrong array, and so on. Okay, for example, uh, when we want to print, right, when we execute a compiler, when we execute compiler, should be a correct language. This is not a correct language because we left the parentheses. So we produce an error, okay, and that will not produce the assembly code. So the compile time error is a error associated with the high level language uh, syntax. So if statement without parentheses, there they have a problem there. Runtime error, now we have assembly code, but assembly code will execute the mathematical calculation. When the mathematical calculation do the calculation, they have a calculation that divide by zero is wrong in mathematics. So they produce an error here, division by zero. So but you already have the assembly code, but when do the calculation, they make a mistake, then the computer will highlight you this is an error. This is runtime error. And when produce an array, the number of array that but you will need to access the location that outside of the array is also a runtime error. The compiler will not know. They try to produce your variable, but the variable is not exist because it's not part of the array. And it will produce a runtime error. Okay. Okay. This is another loop. This is another loop. So remember that first you need to understand the high level language. The high level. Okay. So now is another example. Okay. So to make sure you understand. All right. Okay. What is the difference between this and while statement? The for statement, everybody know all the gadget or for and all the uh, thing that you need to do are inside the for statement parenthesis. Okay. So initial value, we have a comparison of Boolean expression, and then we have an implementation and the change of the value. So all inside the. So how the process? This is important. How the flow of the process? So the flow is like this. I think everybody know. First, they will execute the assignment statement, followed by Boolean expression, and then they jump to body. If true, they jump to the body of the for statement. It's just a printout of the data, and then they process the body is I plus 3. After that, and they print it. After that, they go to back not to the beginning of the for statement, but the second part, which is to go to the Boolean expression. So that means they go to the assignment statement once, the first time. Second time, they just jump to the Boolean expression, okay, and they do the same thing. After the Boolean expression, they jump back, jump back to the, oh sorry, tadi, after this one, they not go to this one, after this, after the body of statement, they go to the implementation. They execute this first, and then barulah, and then they go to the Boolean expression. Sorry, I made mistake. And then they go back inside. Sekali lagi, for the first time, they go to assignment statement, Boolean expression, jump to Boolean body of the for statement, and jump back to the implementation, the third element inside the for statement, and then go back to Boolean operation, not the initialization assignment statement. They go to Boolean expression, and then do the same thing for the second one, for the third one, and the rest. Okay, increase the value. Check is false. False, exit from the loop. Okay, so you need to create a assembly code that follow that loop, follow that process, follow that flow. Okay, so saya betulkan lagi ini. I want to make it consistent. Uh, Load. So R1 I. Okay, this is R1. I want to make it consistent. This L1. Okay. Very consistent lah. Compare has a load. So first you need to do the assignment statement. This is load 1 to R1, store I to R1, and then load R1 with I, and compare R1 with 4, and then branch oh ini okay. So this is another way to do the thing. So sorry ini saya dah buat dulu. So the correct one is this way. Ini yang so tak apalah, kamu dah. Okay, this is another way to do the looping. Okay, one segment I can do like one segment, but this is another way to do a looping where we are using a complement. Tapi before that lah, saya akan tunjuk yang original one. This alamak. Sorry, I think we need a break. So okay, the greater I occur. So LE, L1, L2, okay, branch, L, branch 3. So this is L3, and this is L2. So this is the same as the same way as we use in the while statement. All right. So okay, this so we check back. Right. So so let's see. This is loop. Then because we later after we jump, we need to start at this location. Okay, so that's why we have L1 there. Oh no. Okay. So branch L1 tidak apa. Okay. So to make it similar to this one, so every time we after the loop, we are go to this location. That's why we put just this I plus plus is just like inside the body. And that's why we have a loop I equal to 1, and then we do the load R1 to I and compare. And before we use LE. What is LE? Branch is less or equal. Branch is less or equal. Okay? Branch is less or equal, so we can get this one lah. And then if true, we go inside this one. If true, we go inside, jump to this one. So we get L2. So this is the component of the program for this one. Okay. Right. So load I to R1, mul 3 to R1, and this is the first time we call temporary value. That's why T1. Push T1 or call println. I think it's okay. We can print Y. You can call println. It's the same. It's okay. Whatever you want is okay. You can write right here or println pun okay. Doesn't matter. And then we go straight to I equal to I plus. We need not to jump because this is always after the body of the statement. That's why we put after the body of the statement. We do the incrementation at actually this is equal to I plus one. That's why we have load R1 to one, add I R1 to I, uh, and then this is I equal to I plus 1, I equal to I plus 1, so I first, this is load I, so this is like I equal to 1 plus I kan. Saya ubah sikit, sorry ya, untuk make sure consistent. Load I, and then add I to 1, ini lebih consistent lah. So actually I equal to I plus 1, so we need to load I dulu, and then baru tambah 1, and then barulah store P2, and then load back RT2 and give it to I. This is equal to I plus mean that I equal to I plus 1. I is the left operand, 1 is the right operand. So that means we load I dulu. Ni mau betul lah. Okay. Okay, this is the same way as Y statement. So we are using the same thing. So remember that we have 6 relational operator that we can write down as a branch with the comparison relation operator. So in one segment we learn about branch is left. Now we have branch is left or equal. So I name it BLE. You need follow this. We have branch is greater. So I put it BH. Branch is high. Kalau greater or equal, we have branch is high or equal, BHE. Later I will give to you lah. I will give to you the 6 branch with the relational operator. And then we have branch with less or equal, like this one BLE, and then the last time is branch with BE and with less not equal BNE and BN. Later I will give to you. And then after that we branch to L1. So that means after we to this one we are branch for the not to this one but with the and after fourth and so on, okay, go to the Boolean expression. Okay. This is so when we skip BLE, go to the next one, we jump to L3. Okay. Okay, so there are another way to do this one. Not so it's up to you. You can do many ways, but as long as they produce the same result. Okay, so we show that what these 4 segments produce, assembly also produce the same thing. Okay, but it's up to you whatever you do for the assembly code, as long as they produce the same thing. Okay, as long as they produce the same thing. I think I need to add one more. This is another way to do that. Okay, for this one, what is the interpreter for this one? Actually, this is the value of I times 3. So the first loop, I going to be the 1. 1 times 3 is 3. So how many times they loop? I equal to 1, I equal to 2, I equal to 3, I equal to 4. Only 4 times loop. Only 4 times loop. So they produce 4 lines of answer. The first line is 4. The first line is I plus 3 is 3. The second line of I become 2. So 6. And then 9, 3. And the last one is 4, 12. And that's all. Only 4 lines of answer. So the interpreter is going to be 3, 6, 9, and 12. Okay. So actually, there are another way to do this by having the complement, the opposite relational operator. Okay. Okay. We jump. Is it a true? Now we jump with the opposite one. The opposite of less or is greater. So instead of we jump to the body with the true statement, now we jump to the body with the false statement because we are using complement. Okay. So now we branch if we have less tadi greater equal tadi sebenarnya silap tadi. Jadi less equal is greater lah. Less equal lah. So and this one is greater than. So greater than is BH. Greater than is BH. So now we go inside the body of statement. If the statement is a true for the complement one, the complement of less equal is the greater than. This is like so this is a greater than, and then we go because false is a true, false you need to go to the body of the statement, true you need to exit. Jadi ini L2 L3 kita pun throw it away. So that means what? That means if this is false, we go straight to the statement. We go straight to the statement. And then we don't need L2. As we don't need L2, we just go straight to the statement. We do the and when it's at the bottom of the statement, the body of statement, we branch to L1. So this is the same. The only difference is we have less number of labels. So this is another way to answer the question by using the complement bullet expression. So to do this way, we need to use the complement of the original Boolean expression. The original Boolean expression is less or equal. The complement of that is greater than. Jadi we have BH instead of BLE. Tapi the good thing about this way, we save one line of code. We don't use the unconditional branch anymore for the false. Okay. So we only exit from the loop by having the true statement for the complex statement. So that's why we exit. To do the looping, is we are using complement. We are using complement. Alright. So the answer, all can choose this way. This is the more efficient way because what? We save the storage. The storage, we save the storage is less number of store, less number of jump. We save a time. 2 jump instead of 3. Okay, only 2 label instead of 3. Alright. Okay, that's all for that. Means by having this, later I will give an example to use if statement selection. So I think that's enough. We have 3 examples here, and then good enough for you to answer all other questions. Hopefully. Okay. All right. Okay. All right. We continue with other sub. I talk about especially a compiler, but a software. There are two representation of certain software. One that we can use it, and the other one is a development phase. The software in development phase. You can run it, but its function. They can the process they can process correctly, but it's not you can use yet because it's not in the machine language code. But they still mean the same. So when we talk about a compiler or any, especially a compiler, we talk about a source language. Well, a source language is the input of the compiler. Compiler is a software. Software needs an input. The input is a source, and the output of the compiler is the object language. Okay, so when we talk about compiler, we talk about source language, about object. And the third thing is the the state of the compiler. Remember, as mentioned just now, either saya lupa nak save record ni, tak apalah yang ni saya tak record lah. Either the software or object language for program. Okay. No, yes, correct. The state of the compiler can be in development program or deployment development stage or the deployment stage. So kalau lah if it's a development phase, they be in the one language. Deployment in another language. Or the language in which it exists. Okay? The compiler can be in the development phase or the deployment phase. Since it might have been translated into a language foreign to the one in which it was originally written. The compiler we write using high-level language. When we want to deploy, we should convert it into another language. So the compiler is the same fate. Dia maksudnya the same thing you need to do and to other program. Because the compiler itself is a program. So we need a compiler program. Sometimes we call it compiler for another compiler. So the compiler need to go through another compiler in order to become a state that it can be used by a CPU. CPU can execute. So that means compiler can be into stage, into two language, either in development or in the to that. Okay, in this class you need to study this one. Ini kita panggil big C notation. In this book, they have a symbol that represents a color. Remember, I said we have a three kind of language when you call compiler. The compiler that is a of the compiler. The input is the left side of the arrow, output is the right side of the arrow. That means because this is the source language we want to execute, so the name of compiler is the name of the source language we want to execute to convert. So this is what the name of the compiler. This is Java compiler, where we want to convert a Java high-level language into a machine code. Okay. So this Java low-level language, the Java we want to run it, we want to get the answer from Macintosh. So that means we need to convert the into a machine code of Mac. And in order to the compiler to work, there must be in the state of the machine they want to. So and you are Macintosh. So the Java compiler should be in the state of deployment, which is a machine code of Mac. That's why it's Mac here. Okay. So that means the state of this compiler is a machine code state. The machine code state. So the compiler is in the machine code. Okay. This is a component that runs on Mac. This is a Java program. Generate Mac program. The same thing, Java to Mac. This statement means the same thing as above. Generate a Java compiler that generate Mac program make machine code program and run on a Sun computer. A Java compiler, of course, they want to convert a Java high-level language into Mac. And then because this compiler, the deployment state is a Sun machine code, so they need to run it in a Sun machine code. So compiler Sun machine code, and then it's a Java running on Sun. But the answer should be run on Mac. So what you can do after you execute the program, you get the output, and take the output, go copy in a thumb drive, go to Mac computer and run it, because they create a assembly code. This is not practical. This is just a theoretical compiler. We almost never do like this. Usually, compiler compile the Java in the same machine of the one that we want to execute the answer to get the answer. But now we run using Sun, but in order to get the answer, we need to go to the Mac computer to run the output of the compiler to get the answer. Okay, this is theoretical, not a practical. This is more theoretical, because this is not usually what we never create a compiler for this. But because the compiler is translator, they translate any language. So in this case, they translate a machine code PC into high-level language. Is the other way. Usually compiler convert high level to low level. Tapi this one, the compiler is only theoretical. You never have this one, but the theoretical is okay. Theoretical, there is a compiler that convert a low level language into high level language. Okay. And this is a development state, because the compiler in the state of high level language is other high level language, not in the machine code. So that means this compiler we cannot use it. We cannot use it. We need to change it to low level, then we can use it. But this is the stage of development. We develop the compiler using other high level language. Okay. So this is an example lah. Ada convert to PC. PC, kalau we call PC, PC is a low level language machine code. So we have a thing. So number B is ADA. Number B is a development stage, because the compiler in the state of high level language. Both in the state of low level language. Sun is a machine code of Sun, PC a machine code of PC. We can run the compiler, but the only practical compiler is A. This is a practical. Ada compiler running on PC, and the answer going to be running on PC. But B we cannot run at all because it's a development stage. And B is as before. Yes, we can execute the compiler, but the answer you should get it and put it in PC instead of Sun machine. Okay, so it's not practical. B and C is not practical, and only A we can use it. Okay. So for this class, we're going to start with logical analysis, and then syntax analysis, code generation, and then we go to robot optimization, and we study all the stages of computer. So this I want to skip because we want to maybe later we come back to here. All right. So this is the stage of compiler. I think almost the same. When you want to compile, when to create a compiler, usually we start with the logical. And then this the thing that we produce token for the interface, atom was in that interface, And then the global optimization is an optional process. Okay, and then the atom will execute after you get atom, we convert into instruction assembly code, and then this is another optional uh, process which is local optimization. Actually, at this stage, we can use instruction. But if you want to make it efficient, we go to the local optimization, and the new instruction will be used for the execution. Okay, this is code animation. Okay. When we talk about all the computer, when we talk about computer or mobile phone, uh, this is the diagram of a mobile phone or a computer. Okay. So when we talk about things that the computer or mobile phone process, you need an input. You need a processor. Processor is a name, the computer processor lah. Computer name considered as a processor of a computer, CPU. Okay. So the computer name is considered as a CPU. If the computer name is a Xiaomi, the CPU is Xiaomi. Okay. And then it's a RAM R1 where the execution will do in the RAM. So that means we need to input the program and the program, the program, the program, and also the input inside the RAM. So before you execute the program, you need to store the entire program inside the RAM, and then you read the input and get the answer. Okay, this is the process lah. This is the process. Number one, number two. I think just review the process. Okay. So we can make it simpler. This is the process of a compiler. Tadi is a general processing of a software. Now, when you to process a software named compiler, this is what you want to do. Okay. First, you need to have a compiler that can be executed by the machine. So the state of compiler should be in the state of M. The machine is M. So the compiler that you want to use must be in the state of M. So that means you can run the compiler because the state of the compiler is M. The machine of the machine, the machine that we're going to run. Okay. And then this compiler with the M state, we name it a S compiler because they convert the S language is to O language. S language is to O language with the same meaning. So that means this compiler will process a language, and this input should be a language. But in this case, it's a language, it's a program in a certain language for a compiler. So we can say this is a development stage of compiler. So that means we want to change the development stage into deployment stage. So S should be the same as S here because the compiler will process the S language. This compiler is written in the S language, but they will change. This is the X compiler. We change the X into Y language for X language to Y language. So the output should be the same. X language to Y language, another compiler, but in the deployment stage. So O is another language. This is a the same compiler as here, but this is a development stage in the S language. Then the same compiler for X to Y, but in the deployment stage in the O machine code. So usually this is O machine code. Okay, so you just remember, right? If you want to use the compiler diagram for the computer, should be M here, S here, S here, X to Y here, X to Y here, O over there, O over there. You must remember this formula. Okay. So the subset language of the compiler, the one inside the computer, M must be the machine language of the computer. And the subset language of the input S must be the same as the source language S or the compiler for the compiler. And subset language, the output should be the same as the object language of the two compilers. So kalau sini, what is the answer? So either to Sun, so they become either Sun PC. Okay. So we just change the header into Sun by using this compiler running on Sun. Okay. And then actually, when we have this big C notation, we can do more than that. By having the equation of we call this equation like equation of using a computer. We can execute we can have a more meaningful way to execute the compiler, to process the compiler. One of that is bootstrapping. Bootstrapping. What is the bootstrapping? The process of using a program as input to itself, as in compiler development through a series of increasing larger subset of the source language. Okay. So this is bootstrapping. This is bootstrapping. So remember that this is just theoretical. It's a macro. We can say it's a macro part of compiler. We only see the big C notation, not actually executing the developing of compiler. Just see as a macro outside of compiler. Okay? Or compiler as a large. Okay, using the equation of the using of the computer. Okay. Okay, so we call it bootstrap. And by using a current compiler, we can create another compiler. That's all. By having a current compiler, we can create another compiler. But what we create, if we want to create a more complex compiler, we can start from the less complex compiler, a subset of the more complex compiler. That means by bootstrapping. Okay, for example, we want to create a Java compiler running on Sun. So that means a deployment stage compiler. So that means this compiler we can run on Sun. So Java compiler convert to Sun, and we can run on Sun this compiler. But so that means in order to do that, in order to create the compiler, it's quite difficult because Java is quite complex. So in order to do that, we create a simpler first. We set a simpler. So sekali lagi to create a Java compiler using low level language is a tedious job. Okay, tengok sini. You nak create Java compiler ni in the state of machine code of Sun. Right. So this is very difficult, almost impossible to do. But to make it easier, we are using bootstrapping. Bootstrapping, we create a simpler compiler first. So instead of you create a Java compiler, now we create a sub of Java. We name it sub, but it is more simpler than Java, but it's working. It's more simpler than Java, but it's working. And we convert this compiler. We create using low level language Sun, but it's okay because it's a simple compiler. Sub. So we create this from the scratch, Sun using Sun machine code, a sub compiler. Nama dia, the name is a sub compiler. So this is in the deployment state lah sebab dia we just produce a Sun machine code. And then after we create this one, we can use it for the sub programming language. So we use a programming language, produce Java, execute the Java program high level language. Java, we create a compiler for Java high level language using a high level language of sub. This is possible because sub is a high level language. It's possible. Although Java is complex, but it's possible because sub is a high level language. And then we produce a Sun, low level language. Okay. So instead of we just creating this one, it's quite difficult because to create a Java complex language, Java is in the complex state of language. Using Sun, now we are creating the same thing but using sub. But before that, we create a compiler, the sub compiler. We managed to do it because sub is a simple language. It's a simple language. Okay. So after creating these two, we can execute. Okay. So now we had a sub that execute the Java language. We had a sub compiler. So we change the sub into Sun. Now we have Java Sun. So finally we can produce the Java compiler. See, this is a Java compiler running on Sun. So without having to create from the scratch. Just create the sub from scratch. Using the sub to create a Java sub into Java compiler using Sun machine code. So this process we call training. Remember, this is only one level. Sometimes we have the Java is the last one is very difficult. We convert from one level to another level. We maybe have sub one, but we have sub two, and then barulah to Java. Do the same process but twice. First sub one to sub two, and then sub two to Java. If there is three level, put it in three level. Produce the three level. So is only one level, is only one line of equation. If you have two levels, there are two equations, and if there are three levels, there are three equations. Almost the same. Almost the same. Okay, this is bootstrapping. Another thing, we have a basic notation. We can have cross compiling. Cross compiling is the if we have a compiler for one machine, we can create the same compiler for another machine. Compiler for another machine, the same compiler. We have a Java in Mac computer. Your company buy a new, but they don't have Java compiler there. So they ask you to create a Java compiler for the computer. But you already have Java compiler for Mac computer. So how you want to do it? This is the way how you want to do it. By using this equation, you can get that one. So first you write the Java compiler that will produce a Mac, Java to Mac, Java to using the Java language. This is okay. To create a compiler using a high level language is okay. So this Java will produce a Mac machine code. Okay. Remember that we already have a Java compiler running on Sun. Your company buy a Mac, but you already have terbalik. Another way, Okay, another way. You already have a Sun machine. Your company buy a Mac machine. So you ask you to create a Mac Java compiler. Java compiler running on Mac. So you already have a Sun machine. You already have a Java running on Sun. So a Java compiler using a Java high level language that can run on Sun. That's not the using the Mac computer. So what you have to do, take this, what you write down, run using the Java Sun, and you get this Java Sun Mac. Remember, this is not the answer, because we want what? We want Java Mac. This is Java Mac Sun. Okay? And then run one more time, because we already have Java Sun Mac. We have this compiler. Use this compiler, the new compiler, to run back the same thing, Java Mac. Now instead of converting into Sun, now we convert it into Mac. So this compiler Java Mac becomes Java Mac. This is the one we want. So in the cross compiling, to do the cross compiling, we need we need to write one compiler. So we produce the compiler that we want. So that we get the compiler that running on Mac. Alright. In Java, actually they call it. So actually in this part we convert from high level to low level. But in certain programming language, instead of they convert straight to the low level language, they convert into intermediate language first, and then from the intermediate language they convert into low level. So we call this language intermediate language. So the primary advantage of this method is that one needs only one translator for each high level language to intermediate form ataupun intermediate language. Each of this is called a front end. Ini kita panggil front end lah. And the first equation that convert from low high level to intermediate form we call front end. And then only one translator interpreter for the intermediate form on each computer. Each of these we call back end. We do another calculation and another equation that to produce the real compiler from the intermediate form to real compiler. What is the advantage? Okay, remember that if we convert directly to the assembly code, this is the first the A example. So if you have two PC and three language that we want to use, so we have two PC, two machine, one PC, another Mac. How many compiler you need? You need 6 compiler. 3 for PC and 3 for Mac. This is a compiler without intermediate form. If you have a compiler using intermediate form, all these 3 compiler will convert to one intermediate form, one language. So this language will convert into 2 machine. Intermediate form to PC, intermediate form to Macintosh, Apple. So how many compiler you need? 1, 2, 3, 4, 5. We need only 5 compiler. Compile this one. Above one, we need 6 compilers. Saved by one compiler. So if you add another compiler like C compiler, so you add, you have another one. So that means ada 8 compiler, but this one you have 6 compiler. Okay. Lagi banyak add more compiler, so you save more. The more compiler you add, the more saving you have, right? Okay. So this is the decaf is a we use a word of decaf for a coffee. Yeah. This is a full blown Java language, Java compiler. So decaf compiler is a smaller Java. So Java compiler that is a 100%. Java, but they just name it decaf. You can so almost the same syntax of Java. So this compiler should be able to execute all the statements here. About the compiler, we're going to talk about formal language. A formal language is language that understand by the computer, that we use it to instruct the computer what to do. A language that we can formulate to use in the computer. So one of formal language is a grammar. But we can use a grammar as a formal language in the computer. This grammar understood by the computer. Okay, so that means we need all the compilers should have their own grammar that the language of pickup written in the definition, the meaning of the definition of the pickup language. So, all right. So this is the first chapter. So the main thing of first chapter, there are 2 things. One is the The way to convert high level language is low level language. Number two is and use the big T notation in order to produce another compiler in the macro part. In the micro part. Micro part is that you need to build it by yourself. But this is by using an equation. That's all for this chapter 1. Saya terlupa nak buka chapter 2. For half an hour, we go to chapter 2. Remember that chapter 1 is introduction to a compiler. Introduction to a compiler. Chapter 2, and in chapter 1, we discussed about, we told you that there are 5 phases of compiler. So chapter 2, we start with the first one, the logical analysis phase. Okay, this is chapter 2 lah. But when we talk about building a compiler to common language, because common language in order to compiler, and common language, the concept is regular expression, finite state machine, grammar, push down machine. All of this you should study in automata class. Okay, but for students lesson 1 this sem, you will going to study that next sem. Probably I'm going to be the lecturer. Okay, but for students lesson 2, you are lucky, you study first. And then now we are using the formal method, the formal language, which is the regular expression and so on, to build a compiler. So, but for students lesson 1, ada disadvantage lah. But it's okay. It's not a very difficult concept. So, language we can be defined by a precise application and is amenable for use with the computer. So, we have a language that the human build that is easier to use in the computer. That's called a formal language. But there are another language also human build for communication, writing between an human. Formal language usually we build it that can be used with human and computer. Natural language is communication language that we can use between a human. Okay, is a human. But sometimes it's quite difficult to convert it into a language that understand by the computer. But now the technology advanced that Google can do that. And Google Translator can understand your language and it can convert to another language. But still, we don't have a compiler to do that. Okay. We still need a compiler to create to change one language, high level language to another. Although maybe Google now will do that for the compiler language, for the high level language. Now Google managed to do the natural language, convert to another natural language. Okay. Please, I think most of you understand this one, but we just be fast. In order to use formal language, you must know this concept. Because when you talk about language, we talk about things, group. So in computer or mathematics, the group we call set. A group we call set. Okay. So in the mathematics, in computer, a group called set. So what is the definition of set? A set is a collection of unique objects. Okay. There are many things. That's why we call it group. Because we have many things. thing group if we call it a group, they have things inside the group. Kalau tak ada benda-benda, it's only one thing, we cannot call a group. We just call that thing. If you have many, like motorcycle, we have many kind of motorcycle. It's a group of motorcycle. So inside that we have Honda, Yamaha, and so on. But if we have only one motorcycle, a Yamaha, so we do call it a group. It's just a Yamaha motorcycle. Okay. A set may contain an infinite number. So that means this book can be infinite number of objects inside the set. But my example is not very good. Motorcycle, because for a set you cannot have multiple objects. That means you cannot have a same object in one group. So one object inside a group, one unique object. That's what they call a collection of unique objects. Okay. So empty set the set or no element. So that means although it's a set, it's a group ni macam it's a place where you put something lah. So the place can be empty. So if the place without any it's a place or group that without any members, we call it empty set. Empty set. We designed it as two curly bracket or this zero slash. Okay, both either using two curly bracket open and close or zero slash. So we call it empty set. Okay. For example, boy girl animal is a set of words consists of three members, and we have the same set of words. Girl, boy, animal, girl. We have two that we need to remove the same object. If the repeat, we need to remove. When we remove another girl there, they become girl, boy, girl, and animal. So going to be the same object. We consider the same object. So the order of the object is not important. We can start with girl and then boy, animal. We can start with animal and boy and girl. With different order, we still consider as same object because the same group because they have the same object. So that means the order is not important. Okay. And then we have another entity for the formal method. Is an object. The description of the object. Actually, the object can be anything, but when we talk about computer language, we are using string as an object. The object is a string in our case. Set can be anything inside the set, but in our case, we are using string as an object. What is string? A string is a list of characters from a given alphabet. So we have a Roman alphabet A till Z. This is a given alphabet A till Z. So you can choose any of the character in the alphabet to form a string. A string, a list of characters of alphabet. Alphabet consists of 37 characters. So you can use any of the characters and you can repeat the characters. It's okay. Okay. The element of the string need not be unique. You can repeat the character, and the order in which they are listed is important. Okay. So different order will produce different string, although they have the same element. Yeah, the same element. For example, ABC and CBA, although they have the same element character with CBA, but they have different order, consider different string. Usually string we put double quotes at the beginning or the end of the string, and the double quote is not part of the string. Okay, and also ABB is not the same as AB because although they have the same element A and B, but the first one have more B than the second one. Although the first one has the same order AB, but they have the third one for the first one and the second one and the B. So remember to differentiate between the set and the object atau the string, and you keep the string. Okay, sampai ini semua. And then when we talk about a string, there are one special string we call a null string, epsilon, a mirror tree, a mirror tree. a mirror tree itu. Tapi we call epsilon, bukan, The mirror tree is a this is important because this mirror tree represent null string, a string without any element. We have a string without an element. We have a string. So although we cannot see because without any element, but it's also considered as a string. To indicate because we cannot represent this string cannot represent itself because there's no element at all. So we give it a name, a representation using a mirror tree. Okay. So mirror tree is very special because they represent nothing, no element at all, but it's considered a string. So example learning from alphabet 0. So that means we can produce a string and become a member of certain set. So for first set, we can create the first set with three elements, three objects, 0, 1, 0, or 1, 0, 1, 1. This is the first set. The second set is empty set. Although we have alphabet, but we not use at all. We call it empty set. The third set, the set of first with a null string, second with 0 and all the zeros. All the zeros. And remember, we can have a, for the set we can have infinite number of objects. So by indicating by dot 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 mean this is the pattern and can be infinite number of this pattern. The pattern is 0 0 0 0 0. I mean all zeros. Okay, the string of all zeros. So actually, we can represent a set not only using a curly bracket by writing the object, but we can represent a set by describing the set by having the set of all strings, zeros and one. This is also a set by describing the set. Sometimes we call a set, we interchange between set and language. Sometimes we call language, sometimes we call set. It's the same thing. It's the same thing. Okay. So now the second example is alphabet. Is a language created by the alphabet of the keyboard. So we have 0, 1, 0, 1. So the keyboard we have 0, 1. We produce the same thing. And then we can also have a 1 with null string. And then you understand all the Java syntax. This also come from the keyboard. Remember? And then all the Italian syntax come from the Roman character, which is inside the keyboard. All the Roman character A to Z is a Roman character. It's from an Italian syntax. Okay. What I mean by Italian syntax? Italian is Italian natural language, Italian sentence. Italian sentence. Syntax ni sentence lah. So Java syntax, Java sentence. Java sentence. Member of one set. And all the Italian sentence, we can say is a member of Italian syntax. Okay. So, part to student, and actually for the CSC, for the student class, for here, right? Student is quite new. Sometimes in the degree part, this is there, where the subject there. Itu all right okay, start. I don't know what to do. Yeah. I think it's time to stop. Uh, so okay, instead of having my picture over there. Oh, lama tunggu ni lama instead of having my picture over there, let stop my picture. Actually, less data involved, and this become my microphone. Okay, if I open the if I open this camera, you will see my mouth. Okay, because this camera become my microphone. All right, so that don't open the video. Okay, the two advantage. First, closer to my mouth. Two, uh, there's a data problem. If I use you will see my face, my video, so less number of data, congestion tu kurang lah. Less congestion. I hope they only convert the voice only. So right now okay, voice. Alright. Okay. So compared to another book, they may have a mathematical explanation, representation of finite statement. It's just a diagram, a concept that have a process, has a process to represent a group. Okay. So we have a machine that can represent a set, a language. Why we need to do this? If we have a machine, the machine is automatic way to recognize a object or the set. So if if this machine can automatically recognize an object of a set, this job, if we can create a machine, that means we can create a computer program to do that. So before we can create a computer program to do that, we create a machine first that can do that, and then we convert that machine into the program that can identify an object or the set automatically. Okay, so before we do the programming part, before we do the program to do that, now we study a concept that concept of a machine ataupun sometimes pakai automatan that can recognize an object automatically by using the machine. Okay, so this is one of the machine kita panggil finite state machine because they are using state diagram. Okay, and they call it finite because you need to use specific state. You don't have any choice. You need to use a specific state to produce to have to have the to have the machine. So they panggil finite specific state. Okay, so this is a theoretical machine. I think it's a repetition of most of you. So the machine consists of a theoretical state, a finite state of state. So that means the main thing is they are using states. The finite set. Finite set is a fixed number of state and a fixed number of alphabet. The state transition. So we specify the machine state given its present state and the current input state. So that means this definition not only explain about uh, the the component of the machine, but also how to process it. Okay, because they say the little bit process of the machine. Okay, so the machine consists of state, and then they use a data. They call input data, input alphabet, and then they have a arrow. We call it a transition by using an arrow. So arrow, that means we go to one state to another state. So a finite state, one of which is a certain state and zero. I think I can go to very fast here. A state extension function. So that means a finite state of state on one which is designed as static state. So that means how to use this, how to create this finite state machine, you must know the how to use it, how to create it. They have a procedure you must follow. You must follow in order to create a machine to represent. Remember, what is a finite state machine? It's a machine to represent a set. Okay, a set of objects. Okay? So this machine must recognize object of state. So the object must mean this object is in the state of, this object is the element. This element is a string. The element of the object is string. And string is combination of character. So input alphabet. So that when they have the one of the element is the input alphabet to create an object. So that what we have input alphabet. By having the input alphabet, you can create an object, and we want to check whether this object, by using the input alphabet or the character, produce the object of the certain set. Okay. So in order to create this machine, you must create also the beginning of the state, the first state that we want to process. So we will go to one state to another state. If you want to go one state to another state, you must have the starting state. So one of the state must become a starting state. Only one, not many. Starting state, we only have one starting state. And zero or more accepting state. Kita ada satu starting state, satu lagi accepting state. And the starting state may be also the accepting state. So kita ada normal state, we have a starting state, and then we have accepting state. Okay, so we have three kind of state. Starting state. Starting state is the name for the state where we want to start, and this starting state also can be accepting state, can be a normal state, and then the rest is a normal state or accepting state. So the starting state can be the normal state or accepting state, and the rest of the state can be accepting state or normal state. A function which has two arguments, a state and input symbol. Input symbol is data that the current data when we process, and with the data we can go, we have a arrow to go to some other state, but we can also go back to the same state. Okay. So return as a result another state, can be the same state, can be a new state. And so how the function works? When we create, we have the machine atau connection atau how to use it. So we need to process a string by break into the string, into the character by character. We process a string, one string only first. To check whether a string belong to a certain set, we must check character by character. So the input is a string of symbols from the input alphabet. The machine is initial in the starting state. We start with a state that each symbol is read from the input string, symbol from the string or the character. The machine proceeds to the new state as indicated by the transition form. Each new symbol will go to another or the same state. We call transition state with the function of the input symbol and the current state of the machine. So that means at the current state, we use a symbol to determine where the state will become a current state. We go to another state, that state become the current state, and we process another string. So that's how it works. So when entire string has been read, so that means the last thing is nothing. You read nothing, that means that all string that you already use for the process. So when we stop at a certain state, they have a meaning. Then machine is either in the accepting state or non-accepting state. If it stop at accepting state, then we say the input string have been accepted. So that means kalau no more character, no more symbol, that means that's all thing that we process one string, because we already read all the symbol in the string. At the end of the string, we stop at certain state. If the state is accepting state, that means we say that we can accept the string as a members of the set. But If you talk at the non-empty state, that means this object or string is not of a certain set that is represented the set represented by the finite state machine. Di cara dia lah. So finite state machine, the set of input string which would be accepted by machine form a language. And we will finite state machine provide a precise precision of a language. That means that's why sometimes the set we call a language. Because in this case, actually, if you can say that natural language, we have a dictionary, right? Dictionary is a collection of words for the language, right? So this is a computer language that this machine can recognize a certain computer language by recognizing words, okay? By having the words. So I mean, we call it language because there represent a word. Okay, this finite machine represent this set represent a word of a language. That's why sometimes we not call a set, we call a language. Then finite state machine can represent a certain language. Okay. This is the example lah. This is the round one is a state. One arrow, the one arrow state from nothing, we call the state with that arrow a starting state. And the arrow can go to other state depending on the input data, either 1 or 0. So the alphabet is 1 or 0. You must have all the input data and transition. Okay. And there are and a state we have double circle. So to indicate this is a accepting state. A state without double circle is a normal state. A state with a double circle is a accepting state. If an accepting state, then means the string that we is a members of this automaton, this finite state machine, or this language, because the finite state machine represent a language. So what is of this language? The language of this, the set of the is a set of a machine that have a string that has zeros and one which begin with a 1 and end with 0. And so you can create a finite state machine by two ways, by having a diagram or having a table. Both produce the same thing. Can represent it by finite. The finite state machine can be represented by a diagram with arrow and state, or by a table. The state in the table represented by a label ABC, and the arrow jump to the certain location in the row of the table. Okay. So that means this is so that means if you create a finite state machine, you must be able to create the diagram, or I also accept in the table form, either one. So you need to create both, either diagram form or the one in the table form. Okay. Remember now, the first row is indicate the starting state, the first row. So the starting should be at the first row. And then see the name of the state, and then the input alphabet. Okay, alphabet to input. So you jump to the another state by having the input state. So if you have a 1, you go to B. So if A have a 1, go to B. So you don't need to go to here. And from B, you get a 1, you go back. From A, you go to 0. If you have a 0 value, you go to D. And then from B, if you have a 0, you go to C. From C, if you have a 0, you go back to C. But if you have a 0, 1, you go back to B. and go back to B and do the same thing. C is the state in the diagram with two star. Star indicate accepting state. So this is to prevent us a set a language of zeros and one, any combination of zero and one that be end with zero. Okay. So the one example is one zero. That one begin with one and ending with zero. 10 is a good example. Let's try 10, no more. So they stop the cut. This one. So that means 10 is a member of this group, this set, this language. What is the language? Language of string of zeros and one which begin with one and ending with zero. The first member is 10. How about 01? 01 is a member or not? Try 01. So 01 is not member because they stop at non-accepting state or non. So sometimes D we call a where we never get we never go will not we there's no chance to become a accepting state. It's simply a member of the state. So it's a dead state. So, but if you have a one, you have a chance to become members of that state until you assess stop at the state is confirmed that that string belong to the one. How about 1 0 stop at T? So 1 0 is member of this language. How about 101? 101. 101 start at B, non-accepting state. So 101 is not a member of that this group. So how about 111? So how about 111? A pergi to 1 to B, B pergi to go to 1, B, B stop at not a member of. So this successful build a finite submachine that really represent all the represent this set language. So that means this represent this set. Okay. So so we have many examples here. We can discuss next week. I think this example. So remember, student special 1, special 2, student special 2. You're not going to find any mathematical representation. All is a description, and all is a diagram and a table. No mathematical representation in this class. Little bit different now from CSC701. Little bit different, the same thing. Finite state automaton, finite state machine is the same thing. Okay, is the same, but in the different representation. But the power of this machine is the same because it's the same thing, but we represent in different things. I think that's all for today. Thank you very much. We're going to have a we talk about 2 hours and minutes. Okay, the notes, and I forgot to record this class. So maybe I give last semester class recording the class lah. But next week I going to record this class. Okay, tadi lupa. Okay, actually because of I play the thing not taking note. Oh, record. No, but the old one. Okay, last two recording, and then but maybe a little bit different. But we do same. Nur Hassan. Any problem you can message to me, and you can message to me. You can ask me. We can see online. You can discuss online personally. It's okay. You can make an appointment. Not only Nur Hassan, everybody. If you don't understand, you can WhatsApp to me, or we can discuss using Google Meet lah. For me, it's Google Meet. Okay, but I will give the recording for the first chapter. Okay, next time. Okay, doctor. All right. Okay, so how many of us? 31. So that means that's correct. 31 including around 30 students. 30 students. I think it's student for master compared to other class. This is the most because we combine. Okay, we combine. And I think for the 2 years, if you have 20 students for part 1, I think it's the most students we have lah for several. Good, maintain. I think this class not very difficult. Everybody can go through, can get at least B, inshallah. Okay, so that's all. Do you have any important question? Because everybody quite tired. All right. So no question. If you have any question, can WhatsApp to me. Okay. Please. It's okay, class. This class is okay. It's okay. Continue. Please continue this program. Don't run away. Inshallah, you can do that. I make sure you can do that. Inshallah. The main thing, you must submit the assignment, and that's the most important thing. Okay, discuss with your friend. You can do the assignment together, and you can submit to me. That's the most important because 30% come from the assignment. 30%. Okay, so that means if you can do the assignment, half of the marks for the pass you already have, and then you need another half, and you take 35 marks to pass the test. So that means the most important thing for this class, nampak you see like it's a bit difficult, but it's not that difficult. You can pass as long as you do and don't skip the test. Please do the test. And usually the project is not for me. It's just an exercise. Okay, the main thing is the assignment. Please do the assignment. Okay. All right. I think we have class after this. Thank you very much. Okay. That's all for me. Assalamualaikum warahmatullahi taala wabarakatuh. Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you.